Okay, so can I explain dependency injection? Bean plant, abso-freaking-lutely I can. Okay, that's a good segue to this. Actuator.digital. You've asked the right dude because this guy has made a pretty cool dependency injection framework. So Flume is like, I believe in dependency injection as a principle for development so much that I use it as the backbone of all of my projects essentially. And so man, actually I haven't done good. God damn it, I haven't done good documentation for this. I really need to do this. I really should have like decent documentation here, but look, instead what we're gonna do is, okay, so you could, when you write code, you could have like, if you've got class A and you've got class B, you can use something called encapsulation, where there might be a variable inside of class A, and then we've got class B as the type, but like inside of it, there's all these different like variables and functions that the classes have. So class A might actually have a instance of class B, and we'll make that green for the purposes of like, all that can go green. So this is an instance of class class A. But what happens if now, like, you can instantiate this, but class A is a instance of an interface. So I interface A. So I interface A has like some behavior. And so it has that method some behavior. And that behavior comes from the interface, right? It's nearly 2 a.m. Yeah, you're right. We're gonna go to 3 and no later. Okay, that's it. So we've got like one night. We got. You were totally right, weren't you, Goldie? It's bedtime. We are gonna finish up this feature though. I'm so close. No longer than 3 a.m. though, I promise. So you're not missing much, Goldie. I absolutely promise. Dolly, I'm gonna get hold of it and put it as my emotes. I'm jealous of this one. Nacho, mod Nacho, yeah, right. You're gonna get hold of that one. Okay, I was wondering if you meant my one, because I was gonna try and pass that on, but we don't need to do that. You're not going yet. That's for Seb. Oh, yeah. You're saying, yeah. You're ringing the bell. It's bedtime. I'm just going to finish off. I'm going to finish off this one feature before I go, Goldie. I'm going to finish this one thing off, and then I'm going to go to bed, okay? Because I'm going to gym with Oasis and Fastfee in the morning, and I don't want to be completely dead. That's 7 hours from now. I'll be leaving for the gym. So we really have to stay locked in. Okay, so if we've got class A and it uses interface A, what we actually want to do here is, instead of saying like if class B uses class A, we might have this thing where it instead uses interface A. And so that interface, right, that needs to, if it comes into our system, it needs to, like, what happens if suddenly we get class C, right? If we get this other system, whoopsie daisy, we get this other system, which is some other class, and it needs to, we want some way to centrally control what happens here, right? And we don't want to go into class A and change class A all the time, everywhere. So what we instead want to do is have this thing which is important for this concept, and that's our dependency injection container. so this dependency injection container in it, what we can say is we can say for interface A, we're going to use class C. And so what happens is when class B starts, it goes and it goes and asks our dependency injection container, hey, what should I use for interface A? And it is going to return, class C, right? So as part of its process, it's going to return class C to be like, that's what I should be using in place of interface A, right? Right, so class C gets put in here. But what you can just as easily do is say, actually, no, I wanted this to be, so where did I say interface A? To clarify, we're going to use that. We're going to use that. And so interface A is then going to get, it's going to get class C, because what happens is this dependency got injected. But later we could actually just say, no, you know what? I don't want this to be class C anymore. I want that to be class A. And then the whole system, what's happened here is it changes to use class A. And why this is really, really cool. Let's see. Who originally asked this? Beanplant. Why this is cool, Beanplant, is I changed the entire behavior of class C by simply changing one line here from class A to, I changed all of the behavior of class C by changing class A to class C. By changing one little like very simple thing, I've completely changed the way that my system works without needing to change this or this or this or this. And so the other thing is this might have multiple dependencies, right? It could be the case that this depends on like a whole bunch of different interfaces and a whole bunch of different systems. So this could be, you know, interface D might be a thing where that also has some different behavior. And so if this was like, so you can like, and you know, you can essentially just by like having your dependency injection container have a bunch of these different things, you can change very quickly how the system behaves in very, very interesting and complicated ways, right? So yeah, that's like a long explanation of, or a short explanation really of like why dependency injection exists and what it does. But like, that's the short of it, is you can completely change the way that systems work without changing the systems themselves, but just by changing what the dependencies are. And then multiple things can also like call on these things. And so throughout the entire project, you could go with one line and like, you know, like class B, there might be class, well, I mean, what did we do? We had like, we have another system. If we have another system down there, that's like, this is class E, and then all of that is like using, all of that has like, we're running out of colors. So that can ask the dependency injection system, and then this goes and like changes, essentially, you know, that changes it everywhere then, right? So like by making one change in the centralized place, we can have all the different dependencies update through this like dependency injection container. And it's really powerful, especially when your solution gets really big and complicated. It decreases coupling and increases cohesion. It makes it so that you can like, it really helps with the, open-close principle as well, because you can extend the behavior without changing anything, and it means that things are more easily substitutable. It helps with like segregating your interfaces, and it more than anything helps with inversion of dependencies. And because now what you have is like class E and class B don't depend on, they no longer depend on like, you know, they no longer depend on class A and class C. they depend on this interface, and the behavior of the interface can be really quickly changed throughout the entire project. So yeah, I hope that helps clarify what exactly happens with this system and why it's powerful. But yeah, and I should probably clip this as a